Good morning, children. As I have informed you yesterday, this Friday you'll have the test of refraction through a lens. So let's quickly go through this chapter, what all you have to study. So the first few pages, nothing much important is there. Straight away you can come here. Okay, all these points are important. Okay, if medium on both the sides are same, first and second focal lengths are equal. Second, usually when we say focus, we mean second focal point. Okay, then convex has real focus, concave has virtual focus. Okay, so this they can ask you the difference between real focus and virtual focus or something like that. This one, if the parallel rays are not parallel to the principal axis, then you will get an image formed in the focal plane, not on the focus but on the focal plane. Same way for concave also, you will not get an image there but at the focal plane. Then we have the fifth point. The focal length of a lens depends on following two factors: refractive index of material of lens relative to its surroundings. Okay, so what are the two factors affecting, they can ask, or they can ask how will the refractive index change if a lens is placed in water instead of air. It's like that. Okay, then what will happen to the image if the part of the lens is covered? Focal length remains unchanged, only the amount of light entering the lens decreases, due to which intensity of image decreases, but position, size and nature of image do not change. So come straight to the B part, where you will have the ray diagrams. Start with convex, so you'll have 7 ray diagrams. Okay, so all the ray diagrams, please draw and practice and go through the characteristics. So I want you to pay attention here that at infinity it's highly diminished, beyond 2f1 it is diminished, at 2f it's same size. Now this is highly diminished and then diminished. Okay, they both are not the same. So if it is asked, draw the ray diagram for a convex lens when it forms a highly diminished image, you should take this. Or if it says magnified, then you have to take between f1 to f, highly magnified at f. Okay, so be careful with the size of the image. Even these things matter a lot. And then applications also, so you can have questions based on applications also. Then concave, so this is the only diagram, an object is anywhere in front of the lens. Okay, so now what will happen if the object is shifted towards the lens? Image also shifts from the focus towards optical center and its size keeps on increasing. This conclusion is important. Then when the object is at a distance equal to focal length, sometimes they can specifically tell you draw a ray diagram for a concave lens with the object at a distance equal to the focal length. So if this is 2 centimeter, you have to take your object also at 2 centimeter and then you draw. Then what happens? The image will be formed exactly between the optical center and the second focus of the lens. Optical center and the second focus of the lens. So this is all about B part. Then coming to C part, one numerical definitely comes, okay, based on lens formula and magnification, one numerical definitely comes. Then definition of power of lens, unit of power of lens, and then power of concave lens is positive, sorry, convex is positive, concave is negative. Then come straight away to application of lenses. Okay, so this is comparatively a smaller chapter when compared to the previous chapter, so you should be able to do it well. I thought I'll just discuss few board questions. It looks easy, but then the way questions comes sometimes is not confusing. You need to really um, think a lot. Okay, so I just thought I'll discuss few questions with you. Turn to page 308, page number 308. So this is 2018 question paper. Okay, last year's question paper. And this was a part A question. State the position of object in front of a converging lens, means convex lens, if it produces a real and same size image of the object, if it is used as a magnifying lens. If it produces real and same size image, then object should be at a distance 2f in front of the lens. It is used as a magnifying lens between optical center and focus of the lens. Then 311. So this was another question the same year. An object AB is placed between O and F1 on the principal axis of a converging lens, means convex lens, as shown in the diagram. Copy the diagram by using 3 standard rays starting from point A. Obtain an image of the object AB. Now usually we use only 2 rays. Here they are asking you to take 3 standard rays. So how will your diagram be? So this is your convex lens, converging lens, optical center, principal focus, and you have an object here. So the first ray parallel to principal axis after refraction passing through F. Second ray passes through principal focus, and then the third ray passing through focus. So what you have to do, you have to keep your scale and join these 2 points. So you have to have a bigger lens. Okay, then only this ray after okay children, so the first ray parallel to principal axis after refraction goes through principal focus. Second ray optic center. Now third ray, what you do, you try to take object little shorter, okay, and the lens little longer. So what you do, you keep your scale and draw a line touching the focus and this point, and it's straight line coming here. Okay, so this is a ray passing through the principal focus, ray from the object which is passing through the principal focus. Now how will this ray go? It will go parallel to the principal focus. So we have 3 reflected rays now, this, and this, and they are not going to meet, and so we extend them backward. So this one and this one. Okay, so AB is the object, A dash B dash is the image. Okay, so this is little difficult, but just practice it. Twice in previous board exams such questions came. Draw the, using 3 incident rays, draw a ray diagram. Okay, now one more question paper, 317. Turn to page number 317, question 3A. 317, question 3A. If the lens is placed in water instead of air, how does its focal length change? So I told you from the A part, focal length increases. Which lens, thick or thin, has greater focal length? A thin lens has greater focal length compared to a thick lens. Then question 6B. Question 6B. Yeah. A virtual diminished image is formed when an object is placed between optical center and the principal focus of a lens. Okay, virtual diminished, then it should be concave. Okay, and they have, just to confuse you, they have given when object is placed between optical center and principal focus. So as you know, you can have object anywhere. So when you draw this diagram, you have to take your object between F and O, somewhere here. Okay, object should be somewhere here. So your first ray parallel to principal axis, then you join them, and then it will go like this. Second ray passing through optical center, goes and comes back. Now these two rays will meet here, and this is the image. So AB is the object, A dash B dash is the image. Sometimes they'll tell you to take the object at F, so then you can take it as F. Just to confuse you, they'll give you the position, but actually it can be between F and O, or at F, or beyond F. You're going to get the same type of image. Okay, so be careful, don't get confused. Name the type of lens. Draw a ray diagram to show the formation of image with the above stated characteristics. Okay, so then one numerical will definitely come up based on lens formula. Object is placed at a distance and all that, right? In the previous question paper also, one question was based on that numerical. So see, again, C part of that same question, C part, it was like this. Okay, so this is to just give you an idea about how the questions can come in this chapter. Okay, so that's all, children. You can start preparing, and if you have any doubt, you can WhatsApp and ask me. Thank you so much.